realize how much damage the sentence is going to lots of I'm trying to find out. I was like, oh, shit, I'm actually
Definitely not. Let's hope some people maybe trickle out today or last week.
I also did all of it.
I just thought it was big. And then here's some video clouds. So like, I guess it was like $10. It's like cloud right now. It's like say there's like yeah, and it's like it's not up to it's just lots. It's chill there.
So I guess I'll do a couple slides and then I'll hand it up to you. Okay, we're good? Okay, everybody, we're gonna go ahead and get started. Thank you all for coming out to our first actual workshop of the year, I guess quarter two. We're gonna be doing an introduction to AWS. So before we do that, so if you're interested in, if you're not on the mailing list, definitely scan this QR code here and fill that out. And then Daniel.
People haven't already joined the theory planning track or the theory track planning team that's going to be launching next quarter, and you're interested in new just fill out the form. And emails for setting up a weekly meeting time will be sent out like tomorrow. So yeah.
Cool, yeah, and then an update on interns. We said we were going to introduce them today, but ACM board has been having some troubles with that. So probably next time. Just keep an eye out. Does anyone still need these? Cool. Okay, here's the event code. We didn't have one last time, but now we do. So if you want 30 points or whatever, it's there. Okay, yep. Yes, I think I just dropped them in the Discord under resources for workshops. Okay. Does anyone need the code still? Anyone still need it? Okay. And then a quick note on how we're going to plan to structure these workshops. So we're going to kind of have like a little bit of a lecture portion that's interspersed with very short demos. And then at the end, we're going to kind of build up our guided project. So if you missed GM or didn't catch the recording or whatever, we're basically going to be creating a very simple clone of Facebook so that we can create a full stack app and then deploy it with AWS using the architecture that's outlined there. So yeah, if you don't know any of those, like how to use AWS at all, that you're in the right place. Don't worry about that. But yeah, just getting to how we're actually going to structure the workshops. We're going to be doing the project together in a guided session, like sense, and then we will have kind of a step-by-step in the README in the GitHub that you can actually follow if you want to kind of replicate it yourself. And then there are additional features that you can add on to build off of the project if you're looking for more to do. But yeah, any questions on that? This is the link to the README here. It's also dropped in the Discord if you need. To the GitHub page, so not the README. Okay. So yeah, without further ado, let's do a short introduction to cloud computing.
All right. So if you went to the GM last week, these might be pretty familiar. These concepts will be pretty familiar, but we're just going to go over them again in a little bit more detail. Okay, so let's say we start a new business, right? We've got Facebook, very original business that no one's ever done before. So let's say we want to, launch a startup and make this into a reality. So we got an idea. What do we do next? Right. The next thing we need to do is actually start building our application, right? And so that requires a lot of infrastructure. And so let's do that. In order to actually set up all our servers and all that, we need to hire a couple people and buy a few things. So we need some staff to actually run the servers, run the code, and make sure everything's working correctly. We need to buy a lot of hardware, a lot of servers, a lot of GPUs, to run our web servers. and some real estate, right? Either lease or we buy the building outright in order to house all our data and all our servers, as well as office buildings and things like that. And so let's see where the costs actually come from. So on the hardware side, we have storage, where we need a lot of hard disks to actually store our user data. We need to actually buy the servers, which is a lot of compute power to serve our web page. And in addition to that, we actually need network hardware so that our servers actually have the network bandwidth to serve these websites in a very fast amount of time, right? So make sure the website latency is very low. We need some staff, right? Software developers, hardware, in addition to that, like security guards, janitors, just to upkeep the building, make sure everything's nice and tidy. And in order to actually, manage the building, we basically have to get into the real estate business a little bit, right? We have to hire agents, lawyers, in order to negotiate our lease agreements and negotiate our rent, make sure that's all, paid on time. And so through this model, we have to also take care of all of these things, right? We have to make sure our servers are always up, and there's a very low chance of failure. And so the solution to these availability and reliability is to have redundant hardware. So we basically just have a set of servers that we're basically just going to keep up all the time as backups. And whenever anything fails, we have our code automatically detect that and then roll over, turn on our backups, and change the load on the failing servers and redirect them to our backup servers. And in addition, we also have to test this failover process during development, which can slow things down quite a bit in order to make sure that when something does happen, it'll get taken care of automatically. In addition, we also need to purchase some data analytics software, probably like Mixpanel or something like that, in order to see how people are interacting with our site, in order to get data analytics and predict problems before they occur. Security is also very important, right? So we have physical security. All our servers cost a lot of money, like millions of dollars potentially. So if someone can just walk in our building, break the lock and take all our servers, even if they can't get the data because it's encrypted, they're still gonna have a massive payday on like eBay or Craigslist or something like that. In addition, digital security, right? Cybersecurity is a very big threat. Everyone's getting hacked these days, so you got to make sure your network's properly partitioned from the outside world. That's called an intranet. You want to make sure your IPs are masked through a VPN, and also make sure all your data is encrypted, so no unencrypted data leaves your servers while on transit. And so there's got to be a better way. Does anyone have any ideas? It's the name of this club. Come on, someone shout it out. Yeah. Okay. Yeah. So cloud computing is the solution to this. And so basically, we hand off the control to a third party. They take care of the servers. They take care of all the infrastructures and buildings and all that. And we just pay for the resources we use. It simplifies the job for us a lot. And so yeah, for cloud computing, the costs are pay as you go. You basically just rent out hardware, and then they take care of the fixed costs like software developers, sanitation, security, things like that. And yeah, we also don't need buildings to house all of our servers. We can just pay for office buildings or any like develop or like WeWork or something like that. If you're a very small and scrappy startup, and so it decreases the cost of development quite a bit. In addition, for scalability, we can scale up and down internationally with basically automatically. Like AWS can handle that for you if you have, depending on the pricing structure you choose. And then there's also no legal overhead. They take care of all of the like EU regulations, American regulations, like cross international border, like nitpicky laws and things like that. So yeah, we don't have any risk of getting sued either. And so that's a big plus. Like you never want to get sued. And so in addition, they also give reliability and scaling analytics. So you got AWS and providing you a lot of valuable data. And this here's an example of a load balancer. It takes care of that automatically. You don't have to do any configuration. It's all internally set up for you, so you can basically just click and drag, and yeah, it'll get taken care of. And so it has that's called a native CDN, a content distribution network, that makes sure that all of your replications are working together to provide fast access to the end user to your website. And in addition, they take care of the security. Like no one's gonna try to rob a $1 trillion company. They are gonna try to rob a small startup with no money. So yeah, that's taken care of. In addition, digital security. This still requires a bit of work on our end, but yeah, it is much simpler with cloud computing. And so one of the issues that is going to be addressed by during our AWS workshop is like how we manage permissions to make sure that people accessing our resources on hosted on these cloud computing services actually do have the correct permissions. And so, yeah, we see with cloud computing, our problem with the on-premise model are largely fixed. So instead of a large upfront cost that a small startup would not be able to afford, we can just pay as you go, and then we have a hardware reliability guarantee. We can scale up within minutes, and there's pre-configured security settings, so it's a much lower risk of getting hacked.
Okay, any questions on that? On like why we're all here, I guess. Okay, great. So then let's get into what we're actually all here for, which is the AWS stuff. Okay, so what is AWS? It stands for Amazon Web Services. It's the largest cloud provider currently on the market, has the largest market share. On the bottom graph there, you can kind of see Microsoft and Google are kind of coming up, but Amazon has remained pretty stable. So one of the great things about AWS is that it has global infrastructure. So we're going to get into this a little bit more later, but essentially it's launched in 33 different distinct regions. And then within each of those regions, there are at least 3 availability zones, which are essentially just data centers. And then they call these things points of presence. They have 600 of them. They're basically just maybe servers that aren't necessarily a full data center, but can help kind of forward requests to help speed it up if you are trying to access some sort of resource. And then here are some alternatives. Azure, Microsoft has like the next biggest market share, and then Google, and then Oracle is also another option. Okay, so how is AWS actually structured? Well, I like to use an analogy of like your phone or maybe like the Google kind of app suite. So it's basically just divided into services, like the name would imply, and each service is just some form of abstracted cloud infrastructure. So one of the simplest services that they've created, it was actually I think the 3rd service that they made. It's called Amazon Simple Storage Service, or S3 is normally what you'll hear. That's the logo up there. And you can think of it kind of like Google Drive. It essentially just lets you store files that have any format that you like. Another very simple service that you'll see, not as common, but still pretty commonly used, simple notification service, SNS, that you'll hear people say. So this is basically used to either send emails to users or send a notification to another service. So with just these 2 services, and a little bit of another service that we're just kind of abstracting away, you could actually build an app that, let's just say, for example, you're expecting, like you have a team of people working under you, right? And you're expecting them to upload a file at the end of the day. You can build an app that will essentially just monitor S3 to see if they've uploaded that file by the end of the day. And if not, it'll send you an email so you know, and you can go and talk. So that's kind of how the workflow with AWS works. You use these services, you can kind of connect them together to build some sort of like actual app infrastructure, and then it scales up right. Does that make sense to everyone? Okay. So yeah, I mentioned this before. One of the great things about AWS is that it has a global infrastructure, right? So it has 33 different regions spread across the world. There's a little map there that shows where they are. They're always looking to grow that though. And then under that, there are availability zones. So each region has at least 3 availability zones. And I'll get into why that's important once we kind of actually look at the console. And then there's also a notion of an account, so that this is what users actually authenticate with to create services and interact. Okay, so here I've listed some of the main service areas that AWS covers. So each of the services can be broken down into the kind of functionality that they have. Kind of like how if you have a Google account, right? You have Gmail for emails, Google Drive for storage, that kind of thing. So the ones that are bolded here are the ones that we're going to actually be using, and the underlined ones are the ones that we're going to talk about today. Okay, so does anyone notice anything that may look a little strange off of this? Let me give you a hint. So why do you guys think there may be multiple different services under the same service area. Any ideas? All right, well, I will go ahead and answer it for you. Maybe a good way to think about it would be with this databases category here. Right, so there are many different kinds of data that one would need to store. So with that, there are probably different actual storage systems that would be better suited to store that data. Right, if you're storing data that's very unstructured, maybe you want to use a particular system. If it's very structured and it has to be transactional, like for example, you're dealing with a lot of payment data, maybe you want to use a particular system, right? And there are probably different costs associated with the different systems as well as kind of overhead, right? To actually work with them. So that kind of leads us into the different classifications of services alongside along the axis of, I guess, overhead. So maybe some of you have heard this term software as a service or SaaS. This is kind of the most commonly used form of the cloud services that you'll see. They're designed to be used by non-technical users and technical users. And some examples are over there on the right. AWS actually doesn't have a whole lot of software as a service services that it offers, but it does support integrations with all of these and many for the more kind of complicated services that we're going to get into. So some of the characteristics of a software as a service is that it's hosted on some sort of remote server that's running somewhere else. And then users are not responsible for updating the hardware or really interacting with the software directly. Right? If you're using Slack, you basically just use the software. You don't really care who wrote the code or what it looks like, what language it's in, anything like that. Right? So what do you guys think some of the advantages of using a service like this would be? Yeah, go ahead. Yeah, that's great. Anything else? I mean, you kind of hit the nail on the head. Like for example, if Slack is marketing to people, like that's essentially the pitch, right? Like it's a communication tool that's very easy to use. What are some of the disadvantages of kind of trying to use a service like this? Yeah, go ahead. Yeah, exactly. Right. If I'm using Slack, and I want to send like really large video files, for example, right? It's not really designed for that. So it's not, and there's no way to configure it to get it to work that way, unless you actually go in and actually modify it, which kind of defeats the purpose of software as a service. Does that make sense to everyone? Okay, cool. So kind of building off of that disadvantage, next kind of degree of control is this notion of platform as a service. So here, this is designed mainly for developers that have some sort of technical background, but maybe don't want to get all the way into the weeds or like the machine code or anything, right? So some of the characteristics of this is that it can be very similar to software as a service, but it can also offer a little bit more customizability and access to the actual software side. You generally won't get into the actual hardware configuration though. Yeah, and this is like you'll hear the term managed, like a managed service. That just means that it's like partially, like part of the configuration is taken care of for you, and part of it is on you. Right, so some examples of this, maybe some of you have used Heroku to deploy an app before. I've also listed a couple different services here. We'll actually be using all three of these, so you'll get experience with that. Okay. But so what do you guys think some of the advantages going with this route? So with this, you get a little bit more control, right? You can actually specify some sort of, well, in some cases, you can specify some code. Like for example, if I'm deploying an app on Heroku, I don't have full control of all the configuration details, right? I don't choose like, well, I haven't done it in a while, but maybe you don't get to choose the operating system or something. That's just assumed, right? But you have some sort of code that you want to run, and you can actually deploy that code, right? And so a disadvantage would be you still don't have full control. So for example, let's just say you're working for the government, right? They have some sort of requirements where maybe they have to have full, like they can't run anything else on that underlying hardware, except their own code. So this would not meet that. Any questions on that? Okay, so then the last category here is infrastructure as a service. So this is as close as you're going to get to that on-premise model that Daniel was describing, where you like physically have the server in your building. Here you're effectively just renting like a virtual server, but you have as much control as you can. So you can choose the operating system. You could choose like the disk size, whatever, like storage size. They try to give you as much control as possible. And yeah, this is designed again for developers, but it's a little bit more kind of into the weeds than platform as a service. So we're going to be using EC2, which is an example of this. All the major cloud providers have their own kind of analog of that. But after today's workshop, we're going to kind of transition away to more managed services as we kind of take a step back and try to look at the full stack architecture. Okay, any questions on these three categories? Okay, so a quick summary here. You can kind of see what aspects are kind of taken care of for us and what aspects are not. So on the left here, we have the on-premise model. We're in full control of everything. And then as we kind of move through infrastructure as a service, platform as a service, and software as a service, we give away control, but we also kind of gain some sort of convenience, right? We don't have to go and configure everything because we're letting others configure it for us. Okay, so one last opportunity for questions if anyone has. Okay, so let's actually get our hands dirty with using AWS. So I didn't mention this before. It is in the README, but everyone here is going to need an AWS account if you want to try doing these things on your own. You don't have to make it now if you don't want to, because we're going to be kind of guiding you through everything here. And then at the end, we'll have a little bit of a work session where you can do it. You will also need Node.js if you don't have it for the demo that we're going to be doing at the end. So just to keep in mind. Okay, so to actually log into the AWS console, you can just look up AWS console. Then any of the links here should work. There should be a sign in button here on the top right. So I'm going to click that. And then I have my email here. I think the free tier only lasts 1 year. So just keep that in mind. I'm just going to sign in with this is like my second account because the expired. But yeah, once you sign in, this is what it looks like. It'll probably be blank here because you wouldn't have used any services yet. But let's quickly go through what this layout means and like how to actually access it. So in the top left there, it should say services. If you click on that, it will actually give you a list of all the services AWS currently offers publicly. So you can kind of search through, and if you click on these service areas here, it will kind of list off the actual services under that service area. So for example, they should have a database one. You can see some of the services here match up with the ones that I had in the slide before. Okay, so beyond that, on the far right, you can click on that and see your account name, username, and account ID there. So the account ID becomes important if you want to access like services through your own like command line. You're gonna have to provide that so it knows what account to provision those services in. And then to the left of that, we can see it says North Virginia, I believe. That's the availability zone. So you can see on the right, it says like US East 1, US East 2. I believe that's the region. Although I can't remember off the top of my head. I believe that's I think US East is the region, and then 1 and 2 are the availability zones under that region. The reason this becomes important is because every time you create a resource, or for the most part, when you create a resource, you're going to create it in a specific availability zone. What that really means is you're just creating it in a particular data center in a particular location, right? So some resources have like a global scope, so you can create them and then it'll like kind of move it around. But for the most part, you're going to want to keep this value the same up here, because if you change it and then go to the service page, you're not going to see anything there and you're going to be confused. So I'm just going to stick with the default. Okay. And then the last thing that I'll mention here is this button here that says Cloud Shell. So if you click on this, it'll actually go ahead and provision a little command line here. So for the most part, we won't be using this, but Daniel will get into it a little bit. This lets you interact with AWS through like the command line instead of going through and clicking buttons. So once you're a little bit more of an expert, this is kind of primarily the way you'll see folks doing this. And you can actually do it through your own command line on your own local machine. So you don't have to open a browser and open this. But this is just for people's convenience if they don't have everything set up. Okay, any questions on the console? Okay, let's go back to the slides then. And we will, okay, this is just if you want to reference it. And then now we can actually go and try to answer the question that Daniel brought up earlier, which was how do we make sure that people that are accessing our resources actually have permissions to do so, right? So if you actually have your server like in your building, it's pretty easy to make sure that people accessing it actually have the permissions to do so. But with cloud, one of the big apprehensions when it was first coming out was that like we don't have like AWS has control of the hardware, right? So they have the ultimate say over like who has access to like your own resources. So this was kind of a major thing that people were really concerned about. Okay, so to actually work with other people in the cloud, by default, the account that you create is called the root account. So under that account, if you create a service, you have full access to it. And then under your root account, you can create kind of other users. And then people can kind of add their own like username and password. And then with that, you can kind of configure what their access level is. And we're going to get into how like the specific details of that in a second. Okay. So like one of the things to keep in mind though with this is that you always want to follow the principle of least privilege. So what that really means is that don't give anyone any extra permissions, right? Like give them the bare bones. If they're only able to, like, let's just say you have 3 websites, right? And you have a developer that's working on one website. You only want to give them permissions to access that particular instance of that particular website. Right? And so you basically just don't want to give them permissions to access anything that they may not need to work. Okay. So yeah, the way this is done is through what's known as identity access management. You'll see the term IAM. So now that let's just say we've created a user under our root account, right? By default, under the principle of least privilege, what do you think will happen if they try to read that picture, get the picture from S3? So by default, if I'm giving this user the least amount of privilege possible, and I've just created the user, and let's just say they're just trying to read an object, right? That's stored in S3. What do you think will happen? What are you going to say? Yeah, can't read it. Exactly. Thank you. So by default, users don't have any permissions to do anything. They have an account, they can log in, but they can't access any service. So what we have to do is give them specific permissions to access that image, either to access that image or access that bucket, or access S3 as a whole. Okay. So now if we give them, like we assign a policy to them, now they have those permissions, so they can freely access and read and download that object. Does that make sense? Like at a high level, what's going on there? Okay, so let's actually get into what a policy is. Hold on a second. I don't know why that's animated, but yeah, policy is just a set of permissions, right? Very straightforward. They're generally associated with users, or there are other. We'll get into that in a second. But yeah, there's 2 types of them. There are official ones that are already managed by AWS. So these are for the kind of common use cases. So for example, you may have a user that's only working with S3, right? So there's a official policy that gives full access to S3. And then you can make your own either like by actually coding them or by combining other official ones. Typically, you'll see these written in JSON syntax, which just stands for JavaScript Object Notation. And we'll show you what that looks like. It's not too tricky. And these are the 3 kind of key features that you'll see in a policy document. You'll see an effect field. So this just says, am I giving these permissions, or am I taking them away from these? And then you'll see an action field that specifies the actual service that we're giving permissions or taking them away from. And then resource, which specifies a specific resource under that service that that we're actually giving permissions or taking them away. So I think a concrete example to hopefully clarify any confusion there. So this is a policy document that theoretically could show how to access that image. So what we can see is that under effect, we have allow, which is basically saying whoever like user that I'm giving this to has the permission to do these actions. And then under action, we have S3 get object. So that's the actual permission that we're giving to the user, right? They can directly read the object. And then under resource, we're specifying, so this is called an ARN, Amazon resource number. Basically, it's just like an unique identifier for every object or service in Amazon. So we're saying look under AWS, look under S3, and then this is the bucket name. Oh, like essentially just a folder. And then this is the actual object, right? So if we wanted to give access to all objects in S3, what we could do is instead of including this, we could just put like an asterisk here, a star. And that would basically signify this user can read anything in S3, in any bucket. Does that make sense? So yeah, last thing about IAM here, and that you kind of have a high-level overview of what that looks like. Once we have a policy, we have to actually assign it to something. So you've seen that we can assign it to a user, right? I've kind of already showed you in the first example. And then the user can access the image file. What you'll also see is this notion of a role. So basically, by default, the user can't access the image. And then, if the user adopts the role, then they can access the image. So essentially, the policy is associated with this part hat here, right? It's associated with a role that the user can adopt and then give away. Why might we want to use a role as opposed to giving the policy directly to the person? Yeah, go ahead.
Like if there's multiple objects that you want to assign,
Mhm.
then you have it once they get the role, they get all
Mhm.
objects.
Yeah, so I think you're hitting at the right thing. What I'm going to emphasize is think about the difference between just giving the policy to the user directly. So now they can access all the objects, right? And giving the policy just to the role, and then the user can adopt the role, and then once they're done accessing the objects, they can give away them. Yeah, go ahead. Mhm. Yeah, I think you're hitting at the right thing. Essentially, this all gets back to that principle of least privilege again. Right? You only want the users to have permissions to access the objects when they're allowed to do so. So for example, maybe like only during the workday, you only want, so that you could restrict access to the role during the night, right? So that the user can't actually access the object at all. And this also allows users to kind of adopt different roles. So let's just say I'm kind of like a DevOps person. So I do both development and deployment. But I don't want to have both permissions at once, right? So I can adopt the software engineering role, like log into that, do my software engineering, and then if I try to deploy, it's going to say, hey, you don't have permissions. So now I have to log out and then log in with the DevOps role, the deployment role, and then I can actually deploy my changes. Does that make sense to everyone? Why this is the most popular way of doing it? Okay. So yeah, then beyond that, there's also a notion of a group, not too surprising, right? You can assign a policy to a group, and then all the users in the group have that those access permissions. And then finally, this one's a bit tricky, but you can actually assign a policy to a service. So kind of getting back to that example that I tried to bring up earlier, if we want to have SNS, remember that simple notification service, read S3 to see if something exists, it actually can do that if you give it permission to. So you just have to give it a role, and then I guess under the role, people have access to read that. Does that make sense, everyone? You get an idea? So let me quickly show you what an IAM policy will look like in the console. I promise we won't stay too much on IAM. I just want to hammer home like what it looks like because it really is critical to accessing services and having services interact. So yeah, if you go back to the console, you can either click here and search for IAM, which I guess I'll do, and then click on this IAM at the top. And then this is basically the console here. So it'll probably say like 0 roles, 0 policies or whatever. What we're gonna want to do is click on policies because that's what we've been talking about. And then I'm just gonna search for S3 read. Okay, let's just see this one. So it says S3 read-only access. If we scroll down, we can see AWS tries to display it neatly here without any code. But if we switch it here to JSON, we can, let me zoom in also. We can see what the policy document actually looks like. So as you can see, it looks very similar to what we had before, right? It's basically it's giving these policies, right? The effect is allow. And then it's saying, you can get anything, you can list anything, you can describe anything. And then these two policies, which we don't have, or actions which you don't have to worry about. And then it's saying any resource under S3 or any resource in Amazon. But because the permission is S3 get, you can't S3 get like an EC2 instance, right? This is the same as if we did AWS S3 and then stuff. Does that make sense to everyone? What this looks like and why? Okay, great. So yeah, then I'm gonna pass it off to you then. So let me plug in that. You want me to move to the next slide? Cool. Okay. Yep, sorry.
All right, so now we're gonna talk about virtual machines. So why is this important? This is basically what an EC2 is. So you're basically gonna be running a virtual machine on Amazon servers, and you're gonna be accessing it through either the console or like an SSH or something. Yeah, so what a virtual machine is basically just an isolated environment to run your code, right? So you know how on your laptop you have an operating system, right? So a virtual machine is basically running an operating system on top of another operating system, and isolating that environment so none of your code can leak out into the main desktop environment. And here's an image of two different types of hypervisors. So if you ever use something like VMware or VirtualBox, maybe in like your CS 35L class or like one of the or CS 111 class, that's basically what's going to happen. You're going to be running a hypervisor software on top of your main host operating system, and then running like a guest operating system on top of that. So essentially what this means is that you can have like a Windows machine, and you can simulate having a Linux machine running on top of that. But for servers environments, you're typically going to use a type 1 hypervisor. So this means that you don't have any host operating system. The sole purpose of your machine is basically just to run virtual machines split between guest operating systems. And so you're basically just going to have a hardware and directly install a hypervisor on your server, and then install your guest operating system images. And so this basically allows you to have security in the configuration of your software environment. So instead of having to reconfigure your operating systems in order to run your software every single time, you can basically just have a set image, an operating system image, and then just have a copy of that, so you can just like click on it, run it, and then just deploy your software very simply. And so this basically just lets us have portability of our software environment. And so yeah, here's just kind of another diagram to illustrate how we would have to do with a VM and without a VM. So let's say we have like C++ code written and compiled for x86. If we have an x86 CPU, we're fine. However, if our machine's a different version, we're going to have to compile a different version for each hardware architecture. However, if we have a virtual machine, it doesn't matter which CPU is going to be running on our physical machine. As long as we have this virtual machine hypervisor installed on a physical machine, our software environment is going to run just fine. Right, so Amazon EC2 solves the basic problem of needing a lot of money for your servers. And the solution is to basically just give a lot of money to Amazon instead, but like slightly less than having to buy our own servers. And so instead of letting our money sit in our bank accounts, we give it to Andrew Jassy to increase the shareholder value. And so basically we just rent a virtual machine from Amazon, and they handle all the virtual machine configuration and all that. and then or at least the underlying infrastructure part. And then to actually configure the virtual machine, we just go in SSH into it, and then we configure the settings to whatever we want for our software to run in. So we can install packages, we can install like permissions, network settings, things like that in our virtual machine. And so just going over a little bit of terminology. So an image is not like a picture, right? But it's like just an entire copy of your virtual environment. So think of like having Windows installed on a USB stick. So that would be basically an analogy. So we basically just download a copy of our EC2 instance, and then we can just like run our image instead of having to set up a new EC2 instance, and all our data will be saved in that image. And so an instance is basically every time we take that image and start running it, that'll be an instance. So you can have multiple instances of the same, based on the same operating system image. And we can also configure our instances depending on our CPU, memory, or like networking requirements, things like that. However, by default, EC2 does not let you save data. So like you're gonna have like a temporary data store that's called instance store. However, every time you turn off the EC2 instance, like if you save any files or anything like that, they're just gonna be lost, right? And so yeah, that's because it's all saved in RAM, and or if it's even disk, like Amazon wipes it later. So yeah, you're gonna have to buy another service to solve that issue. And so yeah, this is just an example of what it's gonna look like to manage an EC2 server. So in order to actually start it, you're gonna run the top command with all your settings, and yeah, this part's gonna like pop up. And so yeah, here's just a little bit more reference for your EC2 commands. This is just straight off of AWS's website. So I'm not gonna go too much into this. This is just for reference when you actually need to like run these commands on your own. But some prerequisites in order to actually start up your EC2 server is the you need your CLI installed. You have to have your IAM configured, have all that done, and then you can finally run this instance with all your configurations set. And so, as we were mentioning with the non-persistent data storage for the EC2 instance, the solution to that is another Amazon service called Elastic Block Store. And basically, what this does is you basically just rent out a virtual hard disk from Amazon, and you just link that up to your EC2 server. So instead of saving it to Instance Store, which is like temporary and volatile, you save it to the Elastic Block Store service, which is your virtual hard disk. And then if you turn off your EC2 instance and then turn it back on, all your data will be saved in the block store. And then in order to actually use this, you're gonna have to mount a file system, and you're gonna have to format the disk with the file system and then mount it to to your EC2 instance, so that when you go access your EC2 instance, you can view all your files under like a directory path. And so every instance must have at least one volume, which can either be the default instance store or EBS or an Elastic Block Store. So yeah, does this make any sense? Is everyone clear on this? Right. Okay. Yeah, so this is just an example of if you don't know what mounting a file system is, this is all it is. So like think of this as like your hard disk with all your files, all your data, things like that. And then so this is our main file system in our EC2 instance. And so when we mount our disk to the file system, what that means is that we can go into the root directory and just navigate to our physical device as if it was just as if it was just part of our file system natively, right? And so it's basically an abstraction so that we can access different physical disks. We can access data on different physical disks than the partition that our operating system is running on. Right, and so here are some more commands. So like if you want to add an EBS to your EC2 instance, basically run the original EC2 command, except with this option, the ---- block device mappings with all your settings. This is where you're going to be accessing your EBS data in your EC2 instance. And there's some extra settings there. And so the standard size is 20 gigabytes, which is not a lot. You can also map snapshots to an EC2 instance, so you can save your data and just return from where you left off for your this previous image. And then you can also map multiple volumes. So if you say 20 gigabytes is not enough and you want to access more data, you can access multiple. You can put like a list behind block device mappings. And so yeah, we're gonna have a demo now.
Okay, cool. Yeah, so any questions on like the purpose of Elastic block storage or EC2 before we actually get into it?
What is the 20 gigabytes?
Yeah, well, no,
Yeah, so the standard size for an EBS volume is 20 gigabytes. And so yeah, if you just tell Amazon hey, give me an EBS volume, that's basically just the size they're gonna give you. If you want more, you basically have to specifically ask them for it. That's all it really means. So it's like not a hard limit or anything. Just the default setting.
Like how big is like 20 gigabytes in this context? Like, what is it good for?
I mean, 20. It's like think of like how many gigabytes your computer has. It's just like 20 gigabytes. It's just the same thing, right? It's being used as like a hard disk, right? So like if you want to store more data, you have to have more EBS volumes, or just like ask them for a larger volume.
yeah, this volume, it won't be used for anything other than what you want to store. So it's completely up to you what's in. Okay, so let's get into the demo then. So before I actually go and we get into the code, you're gonna need to have Node.js installed. So this will let you create a React site locally. So if you want to do that, feel free to do it now. Otherwise, you can just follow along and do it later. Which is the option I recommend. You also need some sort of text editor to actually do a little bit of coding. So we recommend Visual Studio. There's a link there. You can download it from. Okay. So with that said, I'm gonna just open up VS Code, Visual Studio. Oh. So right now it's just opened up. Like there's no. Okay, hold on a second. You change it to a lighter theme. This one maybe. Okay. Is that easier to read or harder to read? Is that easier or harder? Okay. Is that better or worse? Worse? Oh shit. Okay, sorry. Okay, what was it before? Like modern or something? Dark modern? Okay, we'll just stick with this then. I will maybe zoom in or something without. All right, zoom. Okay, thanks. Okay. So yeah, anyways, what we want to do is open up a terminal in some sort of folder so we can actually create our site. So to do that, you're gonna want to click up here and click on terminal, a new terminal. Okay, so right now we can see it's in my like my own directory, my user directory here, right? Okay, that's not great, but I don't really know where I want it. Let's see. I'll just do it on my desktop. So we'll just copy the path. Okay, come on. Okay, so let's do this. I'm gonna basically change my directory with CD to my directory, my desktop directory. So I can clearly see I've opened up some other things here, right? And I can see where the desktop is. Okay, you know what? Let's modify. Let's do this slightly differently. Okay, so I'm gonna quickly open up the folder that I want here, and then I'll open up VS Code in my folder so that I don't actually have to change the directory. I don't have to know what the path is ahead of time. So I'm gonna go to my desktop, right? I'm gonna right-click this, click Show More Options, and then Open with Code. And what this will do is it will open another window where I'm already in my desktop. So if you know your path to your desktop, you can just do CD and then paste in your location. Otherwise, you can do it this way. Another way to do it is if you click on File up here and then Open Folder. I don't know why I didn't do it this way, but you can actually just choose the folder. But at the end of the day, we are in a folder that I'm okay with creating a new website in. So to actually create it, we will run the command npm. Let me just copy it here. Npm create And then we're specifying a template to use, read at latest. I'm just gonna go ahead and paste this in. So this is gonna go ahead and start to provision the site. That's gonna ask me for a couple of details. So I'm gonna just call it ACM Cloud Winter 24. So that's my project name. And then I am gonna go and choose React because that's what we'll be using. So I'm just using the arrow keys and pressing enter. And then we're gonna just go with plain JavaScript. And then it will go ahead and create the site. And then tell us a couple commands that we need to run. So I will go ahead and run cd ACM Cloud like this. Right. So this will actually go into my ACM Cloud folder up here, where we actually have all the files for our website. And then run npm install. So this will install any dependencies that I need before I can actually run my website. Yep. I use React and JavaScript. Yep. It should be on the slides if you get lost. This will take a second, but yeah, is there anything else that's unclear so far? I know the directory thing was kind of a mess. That should not be a tricky. Okay, cool. So once that's done installing, we're going to run npm run dev. And this will go ahead and start our site so we can actually just see it locally. Okay. So we can see at the bottom here, it says it's using this particular port. Oh, it tried to use this port, but then now it was already in use. So it's trying a different one. And then it gives us a link here. So if I either copy this link or I can hold control and click on it, it will open up this link in my browser. And you can see we have our first site here. So it's really not that tricky to spin up a simple React site. Obviously, we haven't customized anything, but at least we do have a website here. And if we click this button, it will count up for us. One thing that you'll note is if you click the button and then refresh, it won't persist that data. And this kind of gets into why we need that full backend, I guess, full stack, right? This is just a front end. So it in and of itself is not strong enough to kind of persist data permanently. Okay, but so we've actually gone and created our own site there in like 5 minutes. Are there any questions on how that was done? Okay, great. So then we can go ahead and continue on. So now that we have that, we want to actually deploy the site using EC2 so that all of you can just go to like in your browser and look up a URL and then access that same website. So to do that, we are going to need to go back to the AWS console. And then we're going to search here for EC2. And then click on that. Okay. So now that we've done that, you're going to either want to click on instances here or launch instance. I'm just going to click on the button there. And then the first step would be to give our instance a name. So we'll just call it ACM Cloud Winter 24. Am I going too fast or is this okay? It's okay. All right. Okay, it looks like it's okay. So we just give it a name. We're going to leave the image as the default, the Amazon Linux one. But if you want to run Windows or something, you could theoretically change it here. And then we'll leave the architecture. We don't have to change that. Under instance type, this is where you can configure like the actual power that would be behind the instance. So they have some pretty powerful like CPUs. They probably have like TPUs and GPUs and stuff. Like if you really want to go and change it, you're going to pay more though if you do that, and it won't be under the free tier. So you're just going to want to stick with the T2 micro. I think the T3 micro may also be covered. There's a couple that are covered under the free tier, and it should say, yeah, free tier eligible. Okay, we're going to leave this. Actually, we're going to have to select proceed without keep here. But if you want to connect to your EC2 instance, like through SSH, if you're familiar with what that is, this is where you'd set the key pair to actually allow you to do that. The process is not too tricky, but it's not really something that we wanted to focus on here. Okay. We will just leave most of these like network configuration the same up here, but we will want to enable these two. So this will actually let us access the site once we deploy it, without having to go and change any of the security configurations. Okay, here we have our storage. So we're just gonna leave it as the default instance store. We're not gonna change it to EBS. And then I don't think we need to change anything under advanced details. So we should be good to click launch instance there. Right? Cool. So we have our instance now. So if we click on instances, we can see it's right here. So let's click on the instance ID. And then, okay, so we can see it's still pending, right? It hasn't actually started running it. It normally doesn't take long. So let's just keep refreshing. But what we'll want at the end of the day is to use this public IP address there. And then with that, we should be able to access our site. So I'll just show you what it looks like. Actually, it's not even running. So, okay, there we go. It's running. Let's just go to this address and see what ends up happening. So I'm going to copy this and opens a new tab. Just go to this in my browser. Yeah, no, it's not connecting, right? Because there's nothing there for it to have access to, because we haven't deployed it. Okay, so how do we actually connect to the instance and upload our code and deploy it, right? So we're going to want to click this connect button up here. And then for our purposes, to keep things simple, we're going to be using this EC2 instance connect, which lets you connect in your browser. But if you were a little bit more technical, you'd probably want to use this SSH client. And this is where that key pair thing comes into play. You would basically use these commands and type it into your own command line. And then you could use your own local machine to directly send commands to AWS. But we're going to stick with this. So we can leave everything default and just click connect. So this will open it's basically the same thing as opening a terminal on that virtual machine. So yeah, what we'll have to do here is, I think, update the packages. Let me just get the command. Hold on, I have it down. Okay. Okay, so it should be sudo yum update. So this will just update any packages that are by default installed. Looks like everything's already up to date. And then I should get this from the slides. We will need to run this command here. So this command is basically pulling in NVM, which stands for Node Version Manager, which allows us to install Node. Node. So I'm just going to switch back here and paste that in, and then just click enter. So it went ahead and used this curl command to copy over those files. Then what we're going to do is we are going to run this command, which should install NVM. Okay. And then we will follow it up with this command here. So this command will basically use NVM, Node Version Manager, to install the latest version of Node. Okay. Okay. Give it a second. Okay, great. So it should be installed. So next, we are going to run this bottom command, which will install Git. So that will allow us to actually pull in our code, assuming it's in a GitHub repository. So it's just asking me if I want to install it. I'm going to say Y for yes. So one thing that you'll notice is, like, maybe let's just say you want to change the website, right, and then deploy your own site. Obviously, it's on your local machine and not on GitHub. So if you don't want to create a public GitHub repository, you would have to use that SSH technique, and then you can just directly upload the files. So that's another way to do it. We're just going this way because it's very straightforward. But that's not too technically difficult either. Okay, great. So now that we've installed Git, the next step is to actually copy over our site Hold on a second. Looks like it's not in the slides. I will fix that afterwards. But it should be in the README. We basically just want to copy over this repository here with this command. So this command is just going to use Git to clone our site code. So we'll paste that in and run that. Okay, great. So now we have our site code on our virtual machine here. So now we just need to find a way to actually deploy it. So once we have that, we can do cd. Actually, let's run the command ls. So ls will list all the directories in the current path, I guess. So under the home directory. And currently it's just this one folder. This one folder came from cloning the GitHub repository. So I will want to change my directory to this folder. I'm just going to press tab to autofill. And then we want to go under week 3. Week 3. Okay. And then if I type in ls again, you can see all these files are the same files that we got when we ran that first npm install. Sorry, the npm create read that latest. Okay, so we have everything here. The next step is to run npm. I believe it's npm deploy or npm build. Let's check the readme again. npm run build. So what this will do is it will create a like kind of a small optimized version that we can actually go into without having any of the necessary tools to be like a debug version that's kind of cluttered. So let's paste this in for npm run build. Oh, hold on a second. Okay, so it looks like it's not working very clearly. Yeah, that's it. Thank you. Because we didn't install any of the dependencies, so it wasn't able to do. So npm install, you have to run that. Okay, great. So that one's done. Now we can try npm run build. Oh, not like that. If you press the up arrow key, it'll use your latest command. Okay, so what this is going to do is it's going to create that optimized build, and it's going to save it under, I believe, the /dist directory. So if we like do another ls, we can see there's a new folder here, right? So this is where our build files are. We need to find a way to make this accessible publicly. Okay, so to do that, we want to copy over those files to a new directory that's actually publicly accessible, and then we need to change a couple permissions. So we're going to run this command here. So this says sudo, this mkdir, this means make directory, and then it's creating a new folder, Cloud React, under this folder var. So the reason we have to do this is because by default, the home directory is not publicly accessible, but this directory has less restricted access permissions. So by moving that, we can actually allow, when we configure access to the site, it'll work without any permission issues.
Wait, can you say that again?
Yeah, sure. So here, like what the command is doing or why we're doing it.
Like, why would?
Yeah, so we're going to basically use this thing called Nginx, which is, it's a reverse proxy, but all that really means is that it takes requests in and then it kind of points it towards some sort of files. The reason why we need to create a new directory is because this directory is can easily be publicly accessible, whereas a home directory is not. There almost certainly is a way to change the permissions in the home directory, but it's more work than it's worth. This is the default directory that Nginx recommends you use, so that's why we're running that. On default. So you can name this whatever. Yep. This is going to, so you see how there's no dot here, right? It's just slash. That means it's starting at the root directory and then creating var under that. Var already exists by default, and then Cloud React is new. Good question. Any other points of confusion or questions so far? Okay, great. So we've created that directory. Now we need to copy over the files. I'm going to stick to the commands just to try to avoid messing anything up here. But this command here is basically running CP for copy. This -R means it's going to be recursive. So it's just going to grab everything under each subfolder. And then it's saying, look under this dist folder and then copy everything to this folder, right, that we just created. So if I run that, now everything is in that folder with lax permissions, right? So now once we set everything up, we can access it from this file. Okay. So now now that we've moved over our files, we actually need to use some sort of software that allows us to accept requests and point it towards that folder. So the software we're going to use is called Nginx. It's a very common kind of reverse proxy. You don't need to know all the details. All you really need to know is that it's taking in requests and pointing it towards some sort of files. So I just ran that command, which will go ahead and install it. And then we need to do a little bit of configuration for it. So this command here, so I paste it in, is going to basically run nano, which is a very simple text editor. And then it's going to edit this configuration file. We'll open the configuration file. So this is, it's a little dense, but we don't have to worry about all the specifics here. We can just kind of skip down to where it says serve. So here by default, this is the way it's configured. It's listening on port 80, which is default for HTTP requests. And then it is looking under this folder here, I believe, for the files by default. But all files are in a different folder. So we need to change that. Right? And then it also has a couple redirects for error messages to these pages, which we don't have. So we can get rid of those. So what we're going to want to do is basically make it look like this. We're still listening on port 80 because we still want HTTP requests. But we're going to point to our own directory that we just copied over. And then we're pointing to this file here, which if we look at our code, here. This is actually the, okay, whatever. This is actually the file that hosts all the page contents in it. So this is the file we want to point to. You can see it has this in it, right? And then it basically is just using the JavaScript that we're not going to get too much into this lecture. That will be a little bit next workshop. But this line here basically allows us to implement that button logic and the styling and stuff. Okay, does that make sense why we need to change this? Okay, so let's just copy it and paste it in. What's the best way to do this? So I will just go ahead and remove this, the service section and then just paste it in. Yeah, I'm not a master of using Nano or any really Linux text editor. I know some people like to use Vim, so that's also an option. Okay. I think the formatting, I'm not sure if the formatting is critical, so let's just go ahead and save it, and then we will try, and if not, we can fix the formatting. So to save it with Nano, you want to use this right out here. So that's Control and O. And it'll tell you, it'll ask you if you want to change the file name. You can just press Enter. And then to exit, it's Control X. Okay, so now assuming that's everything set up properly, we can go ahead and run this command, which will actually go ahead and start Nginx. Okay, great. So it looks like it started without any issue. So now everything should be set up to actually go and view the site, assuming we didn't make any mistakes. So we want to use that public IPv4 address there. And then when you paste it in, make sure you're making an HTTP request, not HTTPS, like I almost did. Yay. We can see. Let's go back. So, in the route, like up here?
Yeah.
Yeah, good question. So let's try it. So we can put in. Oh, so what port number would you think we'd want to put? Yeah, exactly. So we can see that if we do that, it does work. The reason why it works is because by default, HTTP requests are served on port 8. So even though it doesn't show up there, it is using. If you changed this configuration, you may need to change some of the firewall rules. Like we had to check a couple of boxes when we were going through. You may need to let traffic in on the like a new port. But assuming you did those two things, you should be able to use a different port. So if you want to deploy two different sites on the same server, that would be one way to do it. Okay, great. So now we've basically done everything we set out to do, right? We actually deployed the site and did this live. So yeah, any questions on that process or any of the steps at a high level? I know we went through it pretty quickly. Cool. If not, then that is actually all that we have today. So we will, I guess, allow people to kind of mingle or ask questions. We're technically not allowed to eat inside this room, so we'll probably have to do it out in the hall. We only have 24 sandwiches though, so we need maybe we can have folks line up, and then if there are more than 24 people, we can yeah, or something. But yeah, apart from that, you guys should all have access to the actual README docs if you want to do this on your own, as well as the slides. And next week we will be going through the React code itself, as well as kind of how to deploy it more simply without having to actually use EC2. All right, thank you all for coming.